Okay, welcome back. I just want to tell you how I wired my signals, my 2-wire signals, into my DCC turnout so that they're actually changed with the turnout, when the turnout change. As you could probably see here, there's a couple of little voltage bleeds through on my signals. So to go from this to this, where there's no bleed out, we needed a circuit that rectified it, which is a little circuit I made up for doing exactly that. And this is the circuit diagram. The center line down here indicates that it's just really just two circuits, and one would control one and one would control the other signal. I just do that because I balanced it. You can run them all off one, I suppose, but there's no reason why you can't. But before we get to this, I'll show you how to make it later, but we have to do a bit of understand what's going on. Okay, we've got our 12 volts, minus, plus, and we have a sine wave. Right. DCC runs off a square wave. Then you have, do that again, rectification. The voltage on this sine wave needs to be rectified into a DC. Now you can't, there's two main types of rectification. There's a half wave rectified, which appears like that. And then there's a full wave rectified, which takes this lower portion of the sine wave and puts it up here. And that's referred to as a full sine wave rectified. You would then add capacitors, and that would take out that voltage drop, so you get a pure DC. Might sound a little bit complicated, but that's what we have to do. But we've got to do it with a square wave. So we got our plus 12 volts, our minus 12 volts, and we want just a half wave rectified, which would be like this. We've had this on an oscilloscope, so that's what we're getting. And what's actually happening is to get that bleed through, wrong one, when we get this bleed through, what's happening is this one is dipping down slightly below 0 volts, and then it's going back up to 0 volts, then up, and that's repeated. And it's this bleed through that's creating this additional lamp to light up. How did I get rid of it? I introduced these two capacitors. Now that is the normal circuit that the internet will tell you to do, but it gives me that bleed through. So I actually introduced these two capacitors on the advice of an electrical engineer. Shout out to Brian. So you're not going to get a full wave. You don't want full wave rectified. You only want half wave rectified. Because if you do full wave rectified, it would never be switchable. You'd need a bridge rectifier, and a bridge rectifier, irrespective of input, you're always going to get a constant output. So now I'm going to show you how I made it, and it takes a little bit, but before I do that, I'll show you how I wired it in. This is how I wired it all in. This here is a Smail, which is a tortoise, but just with the integrated circuit, DCC switching circuit board already in it. I didn't buy tortoise and then go buy the DCC signal reader for it. It then goes to, this is a junction box, a connector strip, which everything goes through. So everything black goes to one bus bar, everything red goes to the other bus bar, and the yellow ones go to the turnout and powers the frog. So I've taken, for this board, I've taken my power to the internal switch from both A bus and B bus, and A bus and B bus, and then taken the power to the frog, and that goes to my little circuit board that I've created, and consequently it goes to my 2-wire signal, just one side, the other side. I just do that because I like balancing things. It's just me. And that's with these signals. I don't know if it uses anybody else's signals, but I've built these. They're a local Australian guy, and I recommend him. He's very, he lets you know what's going on, and he keeps you up to date on a regular basis. So we'll put that aside and bring out our parts. Right. First things you know is a perf board. That's a piece of perf board. It's got copper contacts on one side and nothing on the other. And the easiest way I found to cut that is just run a Stanley knife across in between the holes and snap it. Dress it up with a little bit of a filing afterwards. But that's all I've done to give me this. A little piece of perf board that I'll need. Then you'll need 4 diodes. The signals come with 2 for your with the signals, and because I've used them elsewhere, I've gotten another 2. Then you'll need resistors, and then you'll also need your capacitors. They come in pairs. Okay. First, and then all your feed wires, of course, which I've already done. I've cut and tinned them already. So I'll just put on my glasses and I'll show you how I do them, and we'll do it pretty quickly. Okay, first of all, I put my, actually before I do that, I'll just give these a bit of a clean. This is a flux pen. Just give them a bit of a clean. Just so that you are cleaning all the rubbish off them and oil and stuff. They've been sitting around for a bit. Right, the first things I do is I put all my wires in. Which is my first port of call. Just the active and the neutral. So I have to lift them up to see these things. And then we'll put the other 2 in. I'll just solder the stupid things in one at a time, eh? Okay. So we'll just clean out things. Got to make sure you get a clean tip. Put the next one in. Now I always start with the active and the return, because it sort of gives you a guide for the next step. I don't put the frog wires in. Notice that they're all wired the same. I keep wiring consistent. It just makes it easy to work out where you are. Alright, now you can trim these off wherever the cutters are, because we don't need them anymore. Okay, first things you put in are your diodes. Now your diodes have to go in the correct manner. Otherwise, so there's a line on them to indicate which way the voltage will go and which way the voltage won't go. So we'll just clip this bit off, and we'll just get them, just trim them off. Now it's about 1/2 inch that you bend them apart, so we'll just pre-bend them all. Right. Now if you look at our diagram, or my little picture here, you'd notice that they're opposite each other. You can't see that one's buried. So that's what you have to do. One going one way. So we'll go for this, we'll do it on this side. So we go from there to +5, which would be there. Just hold that in place, tack it, give it a bit of solder. Now the next one, which is going to be your return, goes opposite sorry, a bit fiddly, these little holes, goes opposite. To that one. See the gate on the diodes this end, gate on the diodes for the return is this one. They're opposite. They have to be opposite. Otherwise the whole circuit won't work. Alright, hold that in place while we give those two a tack. Then we do the same with the other one, making sure that those diodes are in the right direction. In fact, we'll do the return first. That's that way I've got a clearance. checking that. That's what I was just checking that. Hold it in position. Get in there, where are you? Right, then we'll put our last one. But remember, it's got to go opposite, so it has to go this way. So we'll pass that through. Oops, don't like that. And we'll go around, we'll do it, put it in again. Straighten it up. We'll just straighten that up. And hold it in position again. Is that right? Yep. I'll go for this one first, I think. Now, if the solder bleeds between that terminal and these red wires, don't worry about it. We'll be coming back to do that anyway. So, and just trim them off so you can see what's going on. Okay. Next thing you need to do is your resistors. Now these are 430 ohm resistors, and you'll be wiring these. You only need 4 of them. They come in packs of 8 by the looks of it. So you only need, you've got to wire these in series. We don't need those. Right, now this, and these, it doesn't matter, there's no directional thing, they can be either. So you don't fuss about them, we'll just give them a pre-bend. So they're roughly about 1/2 inch. So these ones you aren't fussed about in direction. They are the critical directional ones. These ones are not. Right, so we'll put that in there. Get our little our pliers again, just to hold them in place again. Just give it a quick look, make sure it's in there. And we'll just do the next one. Just hold it in place. becomes a little trickier later. I did a bit of research on how to join all these up, and there's a couple of methods some people do and some people don't. And I've personally found my particular way is a lot easier than mucking around with it the way some other people suggest. Okay, our last little diode. Yeah, sorry, our last resistor. Okay, we'll solder that in place. I sort of am making an assumption that if you're working with DCC, you'd have some basic soldering skills. It doesn't take a lot of, nothing special about all this. Okay, so that's what we've got. Now, you put in your frog power. And we'll put it in there. Okay. I give a little bit of a gap between the two of them. So you can put them both in. Let me hold them in place. Solder those on. Once again, this is I'm doing it this way so you keep track of what's going on for your capacitors. I don't think I've got that. There we go. That's close enough. Okay. I'll trim them off as well. Okay, now we put in our capacitors. These are 10 nano farad capacitors. So they're little ones. They're not big ones. I don't like putting big capacitors in circuits because if people don't understand the dangers of a capacitor, they can be quite hazardous. Right, with the capacitors, you actually have to wire them in parallel. So in other words, you've got to pick up the active and the neutral and bridge them out, which is what I've done here. And we'll just solder that one in. Snip them off. Because the next one's going to be pretty close. The next one, right beside it. What I'll do is I think I've actually done this a bit wrong, but never mind. You can think, yeah, it's just the way you're going to put it together later. And once again, you solder that capacitor in. normally those in. I think I've screwed up because this one's supposed to be over here a bit, but never mind. It all comes down to joining at the back. Where's my other ones? I have another packet. Where's my other packet? Here we go. This is for the other side, same size capacitors. You want it from there, and we'll put it the same situation. Okay. Snip them off. And the last capacitor. Which will go from there. And we'll give it a break to there, to there. Okay. Now this is where the tricky bits get. You have, I just have a normal, active, and neutral, or active and return out. So your active, we're going to put here, and we'll just solder that in place. But make sure this time it does not join with your capacitor. Just check that that's in there. Yep, that's in there. I'll put the other one in there just to make sure. Negative. I'm going to put that over here. Or your return, negative, return. And we'll just do both of them. Usually I do them a little bit neater than that, and I've sort of messed this one up a little bit, but the result's going to be the same, but anyway. Okay, it's protruding a little bit, but never mind. Now we're going to have to join everything up. And this is where it can be a little bit tricky, because if you're not going to join them up properly, you can short them out. Okay. Now some YouTubers will sit there and say, oh, you use this bit to bridge them out. And I've found that just a complete mess, pain. So what I have a tendency to do, which is what other YouTubers would indicate you do, is just spot them together. You see, I've created a little soldered joint there, a little soldered bridge. There's another one. This one's already bridged, but I'll just give it another bit of extra solder. There you go. And then the same with this one. So you're joining these diodes and transistors together. I've created little bridges there. Right, now this is where it's a bit tricky because I sort of mixed them up a little bit. So it's got to be these four in the corner here. Much easier if they're all spaced together. But those four I think that one's got to be there as well. Yeah, that's got to be in there as well. It's not as neat as I normally do. I sort of screwed it up a bit. Okay, so as long as you keep your negative side, which is this negative side, in return, separate from the active side and the return on the inputs. So again, we'll do that the same on this side. So we join these up. I'm just pulling it away just to make sure I'm getting the right ones. And that should be that should go. That's a little bit. That's actually joined, and I don't want that one joined, so desolder that. There we go. But it must be joined to this side. Should be right. Yep, okay. So that's this one here is my frog wire. And this is the two, and that's my output obviously. So we need that one, and these two form the capacitor, and that one. So we'll join my output to my capacitor. Then we'll join my capacitor. We should have two capacitors. Oh, come one. Usually I have a bit more of a gap between the two, and there's another capacitor leg here that's got to be joined. Okay, but you've got to make sure that the positive side, these two don't join, because that's the active side, that's the frog side. And then the same with this one. Now we've done it's clear there's no gap there, but these two capacitors, one there, just create a little, just a drop, and that one. And there should be one leg here. And that's all there is to it. It's a bit messier than normal. We just clean off whatever. It's a little bit less laid out. But then I'll check that with the multimeter. And this wire should be connected. We'll just do this active wire. Should be connected to there, and these two legs. This return wire should be connected to that, well obviously those two, and these two legs also. Now the other side's just exactly the same. Now the frog wire should be connected to nothing else but that leg, and that output wire. And that's it. It's a simple little product. You can knock it up yourself. Once again, there's the diagram, wiring diagram, and that's what you're trying to get rid of. If you get this bleed through, this will solve your problems. And that's it. Okay, I hope you've learned something today. I know that people have contacted this supplier, my signals, asking them how to do it. Nice guy, actually. Keeps you well informed on the progress of your signals. And I've had long discussions with him. He doesn't get a request very often. People prefer to either run a separate power supply for their signals. I didn't want to do that. I just wanted all to run off the switch motors. And this is how I resolved it. Okay, stay well, and I'll catch you in the next time.